In this lesson, we're going to take a look at how we actually go from a velocity time graph to a position time graph. Now, the first thing we have to remember is you can't actually come up with position from velocity, but you can if you know where you started. So as long as I give you an initial position, then you can figure out your displacements. So let's say I have a velocity versus time graph that looks something like this. We're going to start with, say, constant 2 meters per second for 2 seconds. And then we're going to come down to 1 meter per second for a couple seconds. And then we're going to come to 0 meters per second for a couple seconds. And then we're going to go to -1 meters per second for a couple more seconds. Okay? And so what I have is 2 meters per second. There's my velocity. And then I have -1 meters per second. So I have 1, 2, 3, 4, 5, 6, 7, 8 seconds. So this is time in seconds. Now, if that's my velocity time graph and I want to come up with a position time graph, I'm going to do this twice. I'm going to do it once for a position at the reference point and once for a position in front of the reference point, just to demonstrate how the two graphs are similar but a little bit different. So the first time we do this, we're going to say our initial position is 0. It is the reference point. And the second time, we'll say our initial position is actually 2 meters in front of the reference point, just to see how they're different. Now, first thing I want to do with this graph is I want to divide it up into intervals and see what happens. So, our first time interval is 0 to 2 seconds, and from 0 to 2 seconds we can see the object move with a velocity of 2 meters per second, and so we can get a displacement of 2 times 2, which is 4 meters, and it's positive because they moved away. From 2 to 4 seconds, we can get a velocity of 1 meter per second, and that means our displacement is 1 meter per second times 2 seconds, which is 2 meters. Now, from 4 to 6 seconds, that's 0 meters per second, which means, of course, they're at rest, and 0 times the duration of time is still 0 meters. They didn't move, right? 0 meters per second means at rest. And then from 6 to 8 seconds, we've got a velocity of -1 meters per second. So -1 meters per second for 2 seconds means we have a displacement of -2 meters. Okay? Now we're going to take that information and create a position time graph with it. Now our position time graph, we generally don't need to go behind the reference point. So we can start it at 0. We'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 meters. And I'm going to count by 2's. And this is position in meters. Now, down here we have time, and if we just use the information that we just calculated in our previous graph, then we should be able to figure out where this goes, as long as we know where to start. So our initial position is 0, and we know it's got to move 4 meters in 2 seconds. So in 2 seconds, we've got to get up to 4 meters. Now, what's interesting about this, if we calculate the slope of that line, rise over run, 4 divided by 2, that's our 2 meters per second, right? So we can double check. The slope of position is velocity, and that's still true. So the slope of that line does match our 2 meters per second. Now the next little bit of time, we have 2 to 4 seconds. So at 4 seconds, we need to go another 2 meters. That's all the way up to 6 meters. So at 4 seconds, we need to be at 6 meters. You'll notice this line just got less steep. Had it continued on, it would have been further ahead, but it's less steep because we're going slower. So we're still moving away, but at a lower rate, and so our velocity has less slope. But the slope of that line is 1, right? Up 2 over 2. 2 over 2 is 1, and that matches our 1 meter per second velocity. And then we have this velocity of 0 meters per second for 2 seconds. Now that means we have no displacement, so we're at 6 meters. We're going to stay at 6 meters for the next 2 seconds. So at 6 seconds, we're still at 2 meters. That's that horizontal line. Remember, horizontal line on a position graph shows us that the object is at rest. It's not changing position. And then from 6 to 8 seconds, we've got to go back towards the reference point 2 meters. So we're going to come back 2 meters in 2 seconds. So that's symmetric with this curve, right? Same slope but opposite direction, because now we're moving towards the reference point. So that's the position time graph, because I told us let's start here at 0. But if I had said let's start at 2 meters, how would this graph look different? Well, this would start at 2 and we would go 4 meters from there, which would put us up to 6 meters in those seconds. so we'd be up here. And then we'd go 2 meters in the next 2 seconds, so we'd be up here. And then we'd go 0 meters in the next 2 seconds, so we'd still stay here. And then we'd go negative 2 meters in the next 2 seconds, so we'd be here. You'll notice that's the same graph, it's just been shifted up because our initial position is different, right? Our displacements are the same for every interval. 4 meters, 2 meters, 0 meters, negative 2 meters, but they're in different positions because they started in different positions, which is why we can't actually make a position time graph from a velocity time graph unless we do have the position, the initial position.